I just need to. I think we have all our speakers here. Mr. Moore, would you turn your video off, please? Okay. Because as you could tell, my voice is starting to fade here a little bit. I've asked Leslie Desjardins to handle any of the Q&A that is coming in. I see most of them were answered during that event, but if there are questions, now is the time to either raise your hand or mention in the chat window that you would like a microphone or enter your question there.
Okay, thanks, Dendra. As Dendra mentioned, I'll manage the Q&A. So sorry, first of all, I'll turn my phone off. Do that. Never fails. Never fails the minute you start to speak. Would people appreciate going through the questions in the chat first and then taking questions, or is everybody happy with reading the questions and answers in the chat? Is there a preference? Yes, no?
I think for the folks who for English may not be their primary language, it would help, I think, to just do a quick review of the questions that were asked. And I'm going to ask all of our speakers to unmute themselves, please.
So I'll read the questions, and then the speakers can provide a response. And following reviewing the chat, if people could just raise their hand next to their name, I would call on them to unmute their mic and ask their question. So we'll start with the questions in the chat. The first question from David Cotton is, what is the depth of the wetted column versus the diameter? How is that controlled? This is a question for Kelly, I believe, as it was posted during her presentation. Kelly, can you respond to that, please?
Dave asked a kind of a follow-up question that I think was related, maybe what he was getting at. He asked if the wetted column is significantly more than the diameter. Are we measuring horizontal KFS versus vertical? So I had posted, I happen to have some correspondence from Dr. Reynolds on this topic of anisotropic soils. And so I just posted that in the chat there, but basically what, in case anyone's just listening to this on audio and doesn't have the video or can't see the chat, he says in anisotropic soil where the horizontal KFS differs from the vertical KFS, Guelph or Pask or any constant head permeameter for that matter, normally gives an averaged KFS value that's weighted towards the soil's horizontal KFS value. The degree of weighting depends primarily on the ratio of the height of the ponded height of water to the well radius. So the larger the ponding depth relative to borehole radius, the greater the weighting is towards the horizontal component of hydraulic conductivity. And he says this is due primarily to the simple fact that the submerged surface area of the borehole wall is much greater than the submerged surface area of the borehole base. And he sent me some other resource material. I've got a kind of like a poster, what do you call it, like a poster paper from a conference or something that he attended years ago that kind of addressed this question. So I can provide kind of that summary and links, or attach the papers and send them to Dendra if she wants to make those available after the session here today to anybody who wants to read that in more detail.
Thank you, Kelly. So Yes, if you can share that with Dendra, I'm sure she'll share it with the group, and that would be very helpful. So I asked the question because I hear this from the field quite often, so it was good to get it resolved. Whether the results of the permeameter test are impacted if the permeameter is not perfectly vertical in the auger hole. And that was for Kelly, and she did respond. But Kelly, if you want to just quickly explain that as well, I would appreciate it.
Okay, yeah, I just said, scroll down to where I answered that. Yeah, the short answer is that as long as the permeameter is not, I mean, it shouldn't be, way off at a 45 or something like that, but as long as it's not too far off vertical, it should be fine. It shouldn't significantly impact the test results, because if the water surface in the permeameter, if the permeameter is on a slight angle, as it's sort of leaning against the side of the hole, and I certainly like Jim's idea with the supporting it, that would keep it very vertical, keep supporting it above the well hole. So in the case of soils where it may sink into the base of the hole, but if it's leaning, if the bottom of the hole is stable enough that it's not going to sink, and it's just leaning a little bit, the water surface in the permeameter reservoir is going to be at a slight angle, but that angle is going to be consistent all the way down as the water level falls, and the ponded column of water or head of water in the actual borehole itself is going to be, at the right angle, flat and horizontal. So it's just in the reservoir itself. It may be on a slight angle, but in terms of calculating the flow rate, that it should be an insignificant, and probably, I'm pretty sure if you do the math, it may not even impact it at all, because that as long as you're not moving it around, it's not like going back and forth and getting bumped and hit, or the wind's not blowing it over and it's moving from one side to the other, that would introduce errors. But if it's stable and it's slightly off vertical, it should be fine.
Thank you, Kelly. So David Cotton also asked or commented that the 2001 Tyler tables include a linear loading rate, and wanted to know whether Ireland or the Canadian province include a linear loading rate. So we did respond to this, both myself and representative from Ireland, Billy Moore. So I'll provide my response, and then I'll ask Billy to provide his. So the Western Canadian provinces of British Columbia, Alberta, and Saskatchewan include a requirement for linear loading rate in the system design. Manitoba is planning on mandating that in 2022. So you still have to size your system according to the hydraulic loading rate chart, but the length of the system is determined by the linear loading rate. And the Western provinces utilize a version of the Tyler table. So for their effluent loading rates. Billy, did you want to comment on that? Mr. Moore, if you want to unmute yourself, I'm going to ask.
Sorry.
There
yeah,
you go.
I'm just unmuting here. The Irish system is somewhat complex. The loading rates are typically not linear. In the case of a septic tank system, for example, the loading rates are based on population equivalent, provided the percolation values are within the numbers that Lawrence referred to, in this case between 3 and 50, and these are based on minutes per inch. In the case of polishing filters, in other words, infiltration systems for secondary treated effluent, the loading rates can vary within different bands of percolation values, but they're not linear.
Okay, so then would I assume then that no accommodation is currently made for a shallow restricting layer, such as bedrock or heavy clay, or a water table that would cause the effluent to be, well, more the impermeable layers that would cause the effluent to begin migrating sideways?
No, it's more, it's more that separation distances, there are minimum separation distances that apply.
Okay,
And, you know, they're either separation distance to water table, bedrock, etc.
okay. Thank you, Billy. David, did that totally answer your question? I'll ask you to unmute.
Yeah, I think David left the
Oh,
left the
no,
meeting.
he's here. His name's here. I just don't know if he's here. But anyway, we'll move.
Yeah, I mean, I am here.
Okay,
Dave Cotton, I'm in Michigan. And
Okay.
so, and I think, you know, I've done a bit of work across the country, and there are a lot of, when I think of a linear loading rate, we're really, you know, as you were saying, Leslie, we're really worried, we're trying to protect our unsaturated zone from a mounding water table. As we know, all our systems are recharging our water table, whether it's, even if it's not a confined. And so we have linear loading rates, and Tyler had linear loading rates, which were, and they're based on Darcy's law.
Mhm.
And for many practitioners, they feel very severe. And so one of the things that when we look at that, we look at saying, well, you know, we understand, generally speaking, a Perc test, if you will, is really to determine, based on a vertical hydraulic conductivity, can we get the liquid in the ground?
Mhm.
And then as we start to mound, what's more important is the horizontal hydraulic conductivity, which is often 10 times more than the vertical, you know.
Yes.
And so one of the things that we look at is saying, well, if you want to exceed the linear loading rate, you need to identify or figure out what the horizontal saturated conductivity is. And again, I see the permeameters as provided your height is at least 10 times your diameter, is a reasonable way to determine a horizontal hydraulic conductivity. And
Okay,
then so that's really some of the impetus for my questions there.
thank you, David. So the next, are there any comments related to that before I move on to the next comment in the chat? If anybody has a comment, please just raise your hand and we'll unmute you and allow you to ask your question. So the next question was for Lawrence, or the next comment from Daniel Nolan. For low permeability soils, does the constant head test open the possibility for sites with T-values in excess of 120 to be considered suitable? For instance, particularly where primary, secondary, and tertiary treatment has been catered for prior to discharge to the soil interface, which would eliminate or significantly discount any biomat influence. Lawrence, can you answer that question, please?
The answer is no. So I mean, like the T-value 120, I came up with it from our research. So that was on the basis of the field research we did on drip dispersal systems, and the idea, we had lots of instrumentation, as is the idea with all of this, is that you want to maintain unsaturated conditions in the soil to optimize the different contaminant removal processes that go on, and also so that the water moves more slowly. So, I mean, just to comment on something Jim said, which I think needs to be highlighted. So these tests, you're trying to test the saturated hydraulic conductivity because it's kind of a constant for the soil. So how fast will water move through in saturated conditions? And that's going to be very fast. So the more saturated the soil, the faster water moves through it. And that's not a linear thing by any means for different soils. So, but what we do then for design is, so say if you're taking septic tank effluent, we typically, and I say we across the world, if you actually look at the numbers, I mean, they're not necessarily explicitly written, but in the loading rates, whether they're linked to population equivalent or whatever it is. If you look at it, for septic tank effluent, it's generally around about 5% of that saturated hydraulic conductivity we take then as the design loading rate. And so that takes into account the fact that you want it to be unsaturated when it's working, and it also takes into account the fact that you'll get a biomat that's at the, at the infiltrator surface that's going to drastically slow down the natural percolation characteristics of the soil. So coming back to this point about 120, I mean, this is one of my big issues with the T-value. People focus on 120 or 100. So first of all, that doesn't mean very much difference in terms of the saturated hydraulic conductivity. But then also for that, we're probably down at 10% of the saturated hydraulic conductivity. If it was 11%, it would make them, or it is 9%. It's fairly arbitrary, really, that these values that we're picking. So, really, I mean, again, to agree with Jim, the real reason site fail, a lot of it is to do with some of the other aspects of site assessment, poor construction. I mean, again, we're assuming that the effluent is distributed over that plan area. I mean, the vast majority of sites I see, it all goes down one trench. So, you're multiplying it by 4. There's all these factors that really have a much, I mean, the purpose of this talk today was to look purely at percolation tests. But in terms of the broader picture, I mean, I totally agree with Jim. I mean, it's there's probably too much focus on it. If you look at how it's really used, and the fact that we then scale it down by 20 times, and people get really focused on numbers, don't they? Is it 120, 130? But the 120 came from the results we did in these sites, and then we had a certain loading rates. I mean, the sites we looked at were lower than were T values 90 and 70. But then we extrapolated it using modelling, but to still maintain that unsaturated condition underneath those drip dispersal areas, even in the wintertime. So that's where it came from. So it doesn't really change the value as such. Do you know what I mean? I'd make the same decision as to whether that was suitable or not. So it doesn't really matter how you test that. In a sense, is what I'm trying to say.
Okay. Thank you, Daniel. Did that answer your question?
It's Jim here. Do you mind if I just make a comment on what Lawrence said? Clearly, in the rest of the world, you have different soils than we have here in Australia, but we have a lot of highly reactive clays in Australia. And one of the things about highly reactive clays with a high shrink swell potential is the opposite of what Lawrence just said. The saturated hydraulic conductivity of those clays is very much lower than the unsaturated hydraulic conductivity. In sands and other soils, it's the other way around. Saturated hydraulic conductivity is higher. In clays with a high shrink swell potential, they're nearly always lower. So I just wanted to make that point because I don't want people to fall into the trap of looking at their saturated hydraulic conductivity. So this is where the interpretation of all of the factors you see when you undertake your soil assessment, your land capability assessment, come into play. So you need, you're reporting on your knowledge of the clay as the behaviour, the soil, the behaviour of that soil, and then your hydraulic conductivity. And my background was maths and physics, so I like a number more than most people do. I think that the more information that you get to help you determine that your final assessment, the greater confidence that you actually have in your results, and the less likely you are to end up somewhere where a regulator's pointing the finger at you saying this could have been done better. So, yeah.
So, Jim, do you use the coefficient of linear extensibility to determine what the shrink swell value is in those clays?
No, I don't. I just use my experience because my background is in plants and irrigation and soil assessment. I guess you get a lot of experience over the time. I'm really, really happy that people are now talking about percolation tests and the constant head percolation test. I think that's fantastic. And David Cotton made his comments before. I certainly have never found soils, unless they're a duplex soil, where the side hydraulic conductivity is 10 times greater than the horizontal, the horizontal conductivity is 10 times greater than the vertical conductivity. So that to me is a soil structural issue. And if you're in that situation, then, you know, using Darcy's look, really what we say in soil science is that the downward movement of water in the soil, which is really what you want, right? That downward movement of water in the soil is limited by the most limiting factor you have in your soil. So if you have a duplex soil or you have a zone of compaction and those things, that is where you should be doing your testing. Even if you're in the sand and you're in a duplex and you're still above that layer, go and do your testing in the layer underneath the sand, because that's really, at the end of the day, where most of your water is going to end up going. So it's critically important that you test that the zone of greatest limitation.
Thank you, Jim. So Brendan Cooney's comment or chat was that the constant head method appears to be the way forward in terms of accuracy in calculating soil permeability and freeing up time spent on site to holistically evaluate the suitability of the site to accept and treat effluent. Is there a formula or algorithm that can interpret the constant head data to appropriately size infiltration area, taking consideration of effluent quality and gravity versus pump loading? So I open that up to all of our speakers to respond as they see appropriate. Kelly, would you like to start? Do you have a response to that?
Sure, I'll take a stab. Well, my short answer would be that no, I'm not aware of anything. You know, I have no all powerful formula or algorithm, mainly for the reasons that I mentioned in the beginning of my presentation, that I don't feel that a K value or a Perc value or should be the basis of the sizing of an on-site system. It's just one piece of the overall puzzle, if you will. The other comment I guess I want to make is that when we're doing a permeability test, we're using clean water to measure how it flows through the soil. And if we're designing an on-site system that's going to be dispersing, infiltrating primary treated effluent, septic tank effluent, that is not at all, as I'm sure all of you on the call are aware, that is not the same animal. It's a totally different beast, and all that organic matter and suspended solids are going to cause the soil to clog. And so that is the shortcoming, I guess, if you will, of a permeability test or percolation test, is we're testing with clean water, which is not always it's not a good analogy to the actual type of water that we'll be putting into the soil. If we're going to be designing an advanced, like a secondary or tertiary treatment system, I think it's a better match, because now we're putting much cleaner effluent into the soil, which is, I won't say it's not going to cause any clogging or biomat, because I've certainly monitored systems here in PEI where we're putting fairly high quality, 20 milligrams per liter BOD TSS effluent into a drain field, like a mound system. And after a few years, we're seeing some ponding in some of the trenches. Anyway, I guess my bottom line answer to this is that I see the permeability test as something to help the site assessor, make a judgment call of where they are on that spectrum of soil, texture, structure, consistence, density, all those other things that they should be taking into account, and make sure they're being conservative enough, and that they're, as I think it was Lawrence that referred to, outliers, like taking care of making sure you don't get caught with some of these outliers. And if you think you have a particular, soil texture and structure and density, and you're kind of expecting it would perform like whatever, have a certain, loading rate, and then you do a permeability test and it's barely bubbling, and you get a really low K value, if nothing else, it should cause you to kind of take a step back and go, okay, might I be missing something here? What's going on? Why is my permeability test data not really jiving with the other information that I'm seeing from the soil profile? What else is going on here? And it could be sand grain sizes, it could be density, it could be structure, it could be the salt issues that Jim mentions. It could be a range of things. So so I guess that would be my answer. Now, maybe one of the other speakers on here have a miracle algorithm. I would defer to them if they do.
Lawrence, you're waving your finger. I'm assuming you have a comment.
Yeah, I mean, I agree with everything Kelly said, and I think it'd be dangerous to do that. But I think for the Irish system, it could be very easily. I mean, we have our conversion, if you like, of the T-values into the KFS, and then because the problem is the Irish system is based on these thresholds, and then from those thresholds, that guides you to a certain. It basically does guide you to a loading rate, even though it's kind of hardwired in there. So you could easily, put in your KFS, and it would give you the different system designs. But the problem is that would then take away all these nuances and much better real understanding of the site. So I think it's a dangerous thing to do. But from a numbers perspective, the way the code is actually set up, it'd be relatively easy to do. But I think you'd lose a lot from it.
Okay, Jim, you're waving your finger now, so I'll defer to you there.
Again, I'll be argumentative. So the Australian standard does exactly what Lawrence said there. So it gives you a range of infiltration rates, and then from that infiltration rate, you just look up your loading rate. And your loading rate's so much per square metre. So we always talk about, we do our KSATs in litres per day, litres per square metre per day, if you like. We convert them back, and then you've got your loading rate based on that. So then that just becomes the basal area of your dispersal system. But going back to Kelly, and I'll be a little argumentative here, when you deal with sodic soils, if you're in that part of the world that has sodic soils, so I don't know if we have anybody here from South Africa because they got crap soils like we have, but very low organic matter and those sorts of things, doing an infiltration test with RO water or rainwater or a good quality water will give you much lower hydraulic conductivities. There's a thing when you deal with sodic and saline soils called the electrolyte effect. So if you actually do an infiltration test with the saline water, you'll get a higher infiltration rate. And that is, and that in some regards reflects on, I often wonder whether I should be dosing the permeability test water with gypsum before I start, because that more closely would reflect wastewater that has a salt load attached to that wastewater. So if you were reclaiming sodic soils, you would always reclaim with the saline water. You wouldn't use rainwater. You find that people you deal with in an irrigation sense, they get highly confused when you tell them to put saline water on their land. Don't put fresh water on their land, because the fresh water will actually cause the soil to disperse and give you problems. And that's the same in your trench. So I'm always confounded by this, because we run into a lot of these soils that behave very, very poorly due to the due to their sodicity, and we can treat those soils, and we can get increases of infiltration rate of 100-fold just by treating them with gypsum. So, should we treat those soils with gypsum before we do our Perc test or not? Or does that then become a management issue in the future where the householder might have to dose their system with gypsum throughout the life of the system? It's something I don't have an answer to, but be interested in other people's thoughts.
Okay, thank you. So I'm going to ask if there are any further questions, and if there are none, I'll ask the speakers if they have any final comments, and then we'll do a quick wrap up. And so let's start there. Are there any further questions from the attendees? If you could type them into the chat or raise your hand, please indicate if you have a question.
I've got a quick one for Joanne.
Okay, Ben.
Now, Lawrence was saying that Joanne had the misfortune of having to do a literature review of basically everything of what we were discussing today. And I was just interested in how the literature review stacked up against the presentations today.
I think the literature review was pretty much in line with what everybody has said, you know. You'd be hard pushed to find any recent literature on the falling head test. It's very much a relic from the past, and any of the research that's been done in the last few decades has looked at the constant head test and versions of that. And, you know, that in terms of a percolation test, the constant head test is where all of the research is kind of focused. Well, particularly for on-site applications, like there are other tests that would be used in other applications. And then reviewing all of the standards and that I could get my hands on, there's definitely been a shift towards looking at the soil texture and structure, you know, as an increasingly important way of assessing the soil. And I suppose in Ireland, we're using the British standards, which again, you know, they're quite a, you know, they've been around a long time, even though there has been a few revisions. The part that we use in our code of practice is unchanged really for the last few decades. But I could see from the lit review that, you know, in other jurisdictions, you know, in terms of assessing the texture for on-site systems, there's been, you know, a vast amount of work done really. In terms of grouping soils with respect to their permeability when you've assessed their texture and structure. And I guess my takeaway from all the reading I did was that really, even though falling head test has been used for a long time and we have a level of understanding of, you know, how sites work from using it, it's really not best practice. We should be moving towards the constant head test. I mean, we found the Reynolds solution to the constant head data to be the best in terms of our data, but there still is, you know, you will find different views on that in the literature. Some people will use the Glover solution and will say that this is fine. So I think in terms of solutions to your constant head data, there is, you know, people will have arguments on that, I think still, you know, but for us, the Reynolds solution was the best. And yeah, I think a combination of both seems to be my takeaway, that you should use your constant head test, but also put it, you know, that should just be, as Kelly has said, that's a piece of the puzzle, you know, the site assessment has to include, you know, proper site assessment plus the soil assessment as well.
Mm-hmm.
That would be it, yeah.
Jim keeps charging up huge numbers of tripods and data loggers as part of his, well, you know, replication and or laziness, whichever way that we want to describe it. I was actually thinking that the data log records that Jim's collecting and everything there fits really well in with your project there with Lawrence and everything, but everything's set up on a tripod. You know, there's a data logger there. You can replicate it. It actually sounds like a worthwhile project to push on with. Is anybody else doing it that you've seen? As my cat begins to tell me I could feed him. Yeah.
No, really. I mean, I just thought the data logger sounded like a fantastic idea and such a simple thing to do, you know. I don't think people are really logging this data in any way, you know, in any real way that you'd be able to glean some information from it, you know. But if everybody was logging the data, it would be really useful. You know.
Thank you, Joanne. Richard had his hand up and then Jim. So we'll do Richard first and then Jim. Go ahead, Richard.
Yeah, I think it's been a fantastic presentation, great discussion. Jim has hit it on a few times, and I think it's partly contained in Brendan Cooney's question or comment as well. I think there just isn't enough emphasis on the quality of effluent. A lot of my work is on site with problem systems, and it's not down to the size or down to the percolation tests or percolation values. It's down to the maintenance of the systems and the quality of effluent going to percolation area of the soils. And I think we really need to have a lot more emphasis on that element of it.
Okay, thank you. Jim, you had another comment to make? You need to turn your mic on, please.
Just one thing on that data logging. I am inherently lazy, and because it's a funny thing about science. We have a saying in Australia about covering your ass. There's three things you need to know about science. One is cover your ass, cover your ass, cover your ass. So, the data logging methodology that we came up with enabled me to do a single person to be able to do a lot of percolation tests on a site in a day, right? So I can just go there as fast as the excavator can dig the holes, I can do them. The problem we had was when we first started this, we had an electrical engineer that Ben uses to design his wastewater control systems, and him and myself came together to come up with the data logging. Just be really careful what you grab as a data logger. We actually built one up from components because there are temperature compensating data loggers, temperature compensating load cells, sorry. And you need a temperature compensating load cell, because what we were finding here in Australia, where we can get a 40-degree day when we're out in the field doing this data logging, we actually found out that our systems were making water, not losing water, because the temperature effect on the water. So just be careful. If you want a bit of help with it, contact us. But just be careful that if you are going down that data logging pathway, there is some pitfalls you need to get past before you get going. But for me, the advantage was, and what we do, Kelly mentioned it before about the Guelph system, using the two different heights of water in your column. It's very easy with the tripod we use because it's got a slide up section. So what we do is we just set them up. Then I come back later, just record the time and lift it up. And when you actually have a look at the data set, you'll actually find that there's a change in the infiltration rate. So they're easy to identify. And then you can use the Guelph calculation with the two different heads. So you can just get your vertical hydraulic conductivity. And that's the one that I lean towards, is the vertical hydraulic conductivity.
Thank you, Jim. Steve Thomas put a comment in the chat. I'll just read it out quickly. Great presentations, everyone. Accurate identification of soil morphological properties are key, and the KSAT tests are a great tool to assist in preparing the system design. So thank you, Steve. And I think everybody's in agreement that the permeameter or constant head testing is a great tool to support site and soil assessment. As Kelly commented, the sand modifiers are a key component when doing a site assessment. If you don't know what your sand modifiers are, it can skew your results. Does anybody have any final comments to make before we adjourn for the day? I know us wastewater people will talk all day if you let us, but I'm sure people do have other commitments that they have to meet today. So any final words, last words?
The only thing I would like to remind everyone is that the recordings will be posted online by the end of the week. We'll probably split them up into individual sections for people. People that are willing to share their PowerPoints have agreed to do so, and they will be posted along with the seminar page. Any resources that any of the speakers want to share, web references, papers, we will include all that in the same location. And I thank everybody for your time, and especially the folks who pinch hit for me while I was recovering. And the only thing having sat through this today is change is difficult for some folks. And when you've been doing things a certain way all of your life, this is the way it's supposed to be done. And it's difficult when some research comes along or some other method that it's not a bad thing to look again at why you do things and how you do things. That sometimes, there is a better way. And we hear a lot of garbage talked about on-site wastewater system. And I don't think a lot of people have the slightest clue of the science and engineering that goes into constructing on-site wastewater systems. And today, I think, has demonstrated that we don't just dig holes in the ground and put a John on top of it anymore. So that's my closing comment on this. Thank you all so much. Does anybody have any final comments? No? That being said, folks, I'm going to end the meeting for everyone, and we hope to see you again soon.
Thank you, everybody.
Well done, everyone.
It's
Take
very
care.
informative.
Thanks. Bye.
Thanks.
Bye.